Hello everyone. In this lesson, we are going to find the average value of a function or the average height because the area of a rectangle is base times height, and that equals the definition of the integral from a to b of the function f of x dx. If we want to find the average height, then we divide the area by the base. So area divided by the base will equals to the average height. So the area, it's base times height divided by base, or the integral divided by the base will give us f average or f of c. And f of c is the average height. In example number 1, we want to find the average value of the function f of x equals 1 plus x squared on the interval between -1 to 2. So we use the definition, the average value of a function or the average height, f average or f of c equals the integral from a to b, which is -1 to 2, and the function is 1 plus x squared dx. Now that's the area. Now we gotta divide that by the base, which is 2 minus a -1. So let's simplify that. We have 1 over 3 times the integral between -1 to 2 of 1 plus x squared times dx equals 1/3 times x plus 1/3 x to the third, that is the antiderivative of 1 plus x squared. And we evaluate this from -1 to 2, which equals 1/3 times 2 minus a -1, which is plus 1, plus 1/3 times 2 to the third minus -1 to the third, which equals 1/3 times 3 plus 1/3. 2 to the third is 8, minus a -1 is plus 1. So 8 plus 1 is 9. And we add 3 plus 3, which is 6 divided by 3, equals 2. So the average value of the function or the average height is 2. Let's take a look at the above pictures to review the average height. The average height of the area on the left is 6, meaning at any point along the x-axis or any point C from 1 to 10, we can find the value of the height, which is 6, or the average height is the same everywhere, which is 6. In the middle picture, we have the average, it's also 6, but the function start at 1, and y is 4, and f of 10 is 8. The average is somewhere in the middle, so the c value where the function f of x has the average height is at 5.5, and over the first picture, the average function or the average height, f of c, is 6, and c is everywhere between 1 to 10. Any value along 1 to 10, we can find the height, which is 6. Whereas the second picture, we find the average height, it's when the function is at 5.5. The third picture, there are 3 places where we can find the average of the function. In this case, the average of the function is 7. So there are 3 values for c. C1 is a little bit after 2, and C2 is where the average function is 7, which is about in between 3 to 4. There's another value where we can find f of c equal to 7, and C3 is 8. So C3 is at 8. So f of C1 equals to f of C2 equals to f of C3. And these are all the three values where we can find f average, or the average height, which is 7. In example number 2, we want to find a value c when f average, or the average value of the function f of c, equals to 2. And we got that from example 1 when we solved for f average, and we said that was the integral between -1 to 2 of f of x dx, and we divide that by the base, which is 2 minus a -1, and we got the answer for f average as 2. Now we want to set f of c equal to 1 plus c squared, substitute c into our function, and the f average, or f of c, equals to 2. Now, if we set 1 plus c squared equals to 2, we can find a location where f of c equals 2. So we subtract both sides by -1. C squared equals 1. C equals 2 plus or minus 1. So we found two values for c where f of c1 equals to f of c2 equals 2, which is the average height. So let's take a look at the function f of x. F of x equals to 1 plus x squared. So when x is -1, y is 2, and x is at 1, y is also at 2, and when x is 2, y is at 5, and we're looking at the area under the curve, or between the interval from -1 to 2, we see the average value of the function is at f of -1, which is 2, and f of 1 is also 2. So this is the f average, or the average height, which is 2. Now, what does that look like when we draw the average of the function? The average of the function gives us the average height, which is at -1 and 1. In example number 3, we want to use the definition of the average value of a function to find the average temperature of a metal wire. So by definition of the average temperature, so we say temperature average equals the area under the curve of the function, which is from 0 to 8 of temperature T of x dx, divided by the base, which is the distance between 0 to 8. So we take 8 minus 0, that's the base, and that is our average temperature. Now we are going to use trapezoidal method to find the area under the curve, which is the integral. So we can start from 0 to 1, and the height is 1, and then from 1 to 5, our height is 4. So from 1 to 5, we have the height here, which is delta x, which is 4. From 5 to 6, delta x is 1. So here's another trapezoid. And the last one is from 6 to 8, delta x is 2. Now if we add all these 4 trapezoid under the curve, we will get the integral, and then divided by 8, we will get the average temperature. I would like you to complete the problem and solve for the average temperature. Good luck on your homework, and I will see you in the next video.